Hello everyone. Today we'll be discussing program to compute roots of a quadratic equation by accepting the coefficients from the user. For doing this, you will require the syntax of if, else if and else statements. The advantage of using if, else if is that you can test multiple conditions. So the syntax goes this way. First, you start off with the first condition. If this condition is true, then these set of statements will be executed. If this condition is false, it will check for the second condition. If the second condition is true, only then these set of statements will be executed. So for second condition and for these blocks to be executed, the previous condition should be false and this condition, condition 2 should be true. If condition 1, condition 2 both are false, then it comes to the else block and it will execute these set of statements. That is how if else block works. It is also called as else if ladder. So let's discuss the program. Program will ask the user to give three values, A, B, and C for the quadratic equation. Then you apply the formula to calculate the roots of quadratic equation. Let's see the formula here. So we have three cases here. Discriminant. Discriminant is nothing but B square minus 4AC. What you're seeing here inside this. We will call this as discriminant. B square minus 4AC. So if the discriminant is greater than 0, then the formula to be applied is this for root 1 and root 2. If the discriminant is equal to 0, then the roots are real and equal. So the formula is minus b upon 2a. If the discriminant is less than 0, then these are the values of the roots. So let's see how to write the program for computing roots of quadratic equation. We first start off with preprocessor directive. We'll keep adding header files as and when required. Void main. Your entire program will be written inside these curly braces. Now, since we are asking the user to enter three coefficients, we'll be declaring three variables of float type, A, B, C. Again, extra variables that we need, we will add it later. For the time being, we just need three variables of type float. Printf. Now, this statement will tell the user to enter three values for the equation. So enter three coefficients. Scanf, take the three values and store them in appropriate location. Because it is of type float, the variables are of type float. So this will be, the format specifier will be %f, %f, and %f. Put a comma and now tell the address where you want to store these three variables. So first goes in A, second in B, and third will go in C. You have asked for the values have been stored in the correct variables. Now you need to make sure that the first coefficient is non-zero. Ax square plus bx plus c. So a should be non-zero value. To check that, again you can use if. If a is equal to 0, ask the user to enter the values again. So you can write printf, enter the values again because a cannot be 0. Value of a cannot be 0. And you stop the program. To stop the program, we have exit 0. Do remember, whenever you use exit 0 to avoid warning messages, you can include one more file here, hash include stdlib, standard library.h. If you add this file, you will not receive warning messages. Okay, now let's assume A, B, and C values are non-zero and they are stored correctly in the variables. So now let's go ahead and first calculate the discriminant. So I'll put a comment here so that it becomes easy for you to read the program. Calculate discriminant. And what is the formula for it? B square minus 4AC. Let's call the discriminant as D. I need to declare one more variable. I'll add D here. So discriminant, the formula is B square. b into b minus 4 into a into c, b square minus 4ac. So d has been calculated. I'll show you the formula once again. B square minus 4ac, this part, I'm calling it as discriminant. Now, let's start with the first case. If the discriminant is greater than 0, if d is greater than 0, that is what the first formula is about, discriminant greater than 0, then the value of root 1 will be minus b plus square root of b square minus 4ac is nothing but d, discriminant, upon 2a. First case, when d is greater than 0, your root 1, so root 1 is again a variable. Let's declare root 1 also. You will be having two variables, root 1 and root 2. So root 1 formula, you're going to substitute it here, minus b plus sqrt stands for square root of discriminant upon the whole thing upon 2 into a. I'm writing it as 2.0 because everything is in float. This is the numerator, b square plus sqrt of d. D is nothing but b square minus 4ac upon 2.0 into a. That is nothing but 2a. This is root 1. Now remember, sqrt is a built-in function. So again, this comes from hash include math.h. Any mathematics related function, they come from the file math.h. Again, let's calculate root 2 value. So root 2 is equal to minus b minus square root of b square minus 4ac upon 2a. Calculation of root values is done. Now you need to print the values on screen. When d is greater than 0, the roots are real and distinct. And what are the values? The value for that is printf root 1 is equal to percentage %f backslash t stands for tab, root 2 is equal to percentage %f. And where are these values coming from? For root 1, the value comes from root 1 variable, and for root 2, the value comes from root 2 variable. Once this is done, let's move on to the second case. We have covered the case if discriminant value is greater than 0. That means the first case. If discriminant is greater than 0, these are the root values. Now let's cover this case. If discriminant is equal to 0. So we are using else if ladder. Else if d is equal to 0. If discriminant is equal to 0, the formula for that, as I showed you, it is minus b upon 2a. So we can write it as root 1 is equal to minus b slash 2.0 into a. You can repeat this for root 2 also because the formula is the same for both the roots. Minus b upon 2a. Again, we have to print the statements. I'll copy paste it and make the changes here. So roots are real and not distinct, but this time it will be real and equal. Root 1 value, root 2 value, again will be coming from the same variables, root 1 and root 2. Moving on to the third case, if d is neither greater than 0 nor it is equal to 0, that means final case d is less than 0. In that case, the formula will be calculated as root 1 Have a look at the formula once. Minus b upon 2a, this is the real part, plus I followed by the imaginary part. Similarly, root 2, the real part is minus b upon 2a followed by I and the imaginary part. So again, I'll be introducing two new variables, real and imaginary. So let's calculate the real part and the imaginary part. Real part, as I told you in the formula, real part is the first one, minus b upon 2a. So your real part will be minus b slash 2.0 into a. Imaginary part will be this I, we will be writing it while printing the final answer on screen. Right now, imaginary part is only this much, square root of minus d upon 2a. So that is what we are going to write here, SQRT. It is SQRT, please don't make a mistake here. Square root of minus d slash 2a, 2.0 into a. Now, to avoid negative sign, there is a function called f absolute. Whenever there is a negative number, f absolute will convert it into positive value. So if you want, you can write it here as FABS, f absolute of d. This is again a built-in function which will get the absolute value. So for example, if value of d is minus 2, then f absolute of minus 2 will give you answer as 2. It removes the negative sign. Once the real and imaginary parts are calculated, now you just need to print the statements on screen. This time the roots are imaginary. We'll print the real part first. Root 1 is equal to real part plus I times the imaginary part. Okay. And where are these values coming from? The first percentage f value comes from the variable real. So write real here. The second percentage f value comes from imaginary, IMAG. This I is for printing complex roots. Again, with sign change, we will print the value of root 2. So root 2 is equal to percentage f, this time with the negative sign coming from real and imaginary part. Close void main. So this completes the entire program. These are the three cases. Once when the discriminant is greater than 0, when the discriminant is equal to 0, and the last part when the discriminant is less than 0. Let's save this file. I'll call it as quadratic underscore roots dot c. Compile. There is already a closing here, so compile the code. Printf spelling on line number. Yeah, printf statement. Okay. This time you won't be getting any warning messages because for exit 0 you have already included this file, standard library.h. Compile the code. Okay, if the coefficients are 1, 2, and 3, then the roots are imaginary and the values of the roots are root 1, root 2. Formatting can be done. So if you want, you can write it as \n to print the values on the new line. Again, \n to print it on new line. So let's see the output again. 1, 2, 3. Okay, the roots are imaginary. This is the root 1 value. This is the root 2 value. You can try it out for different coefficients. Once when the roots are imaginary, once when the roots are equal, and the third test case you can have when the roots are real and distinct. Thank you.